email and marks going into a respective element. All right. So basically we are nesting it here. At the end, we have the transformer, which is kind of taking the document and converting it into XML file that we want. So let me go and delete this off and run the program. In this folder, we don't have any file, right? I run this program from here. So you could see that it says XML file generated. All right, so let's go to the folder and see, yeah, there's a file that's generated, that is students.xml. Now I can open this with any tool. Say I open it with Notepad and I see something like this, right? Now I want to format this. I want to format this into, because this is like one single string, which is big, right? So if I want to format it, we have tools that are online. Even you could format it online, all right? So I put this and I say I want like 3 spaces per indent level, which is good. And I format it. Okay, when I click the format, you can see that it formatted the entire XML for me. So the basic thing that it's doing is just about formatting this XML, all right? This is much more readable, right? After formatting, you can see that it's readable. You can see first name as Henry, Lee, and henry123@gmail.com, and you have 70 put in here, which is what we expect out. Okay, so we saw this output after running the program. Now quickly, let me run through what's DOM parser and how do we use DOM parser for parsing an existing XML. All right, so these are the classes that you need to import, which would be suggested by your IDE as well, either IntelliJ or Eclipse. So you have document builder factory, you use the same thing, get the new instance from the factory wherein you get an instance of document builder factory. With this, you create document builder. And once you have the document builder, you parse it, invoke a parse method on the document builder and pass the XML file name. All right, so whatever XML you want to parse, you would send it across. Now, once you have this parsed, if you want to get the node name, if you want to display something like what's a root element within your XML, you could do something like this: doc.get document element and get node name. So this would basically display the first element that you have within your XML, which is nothing but the root element, right? You could read based on the name. You have the tag names or element name. So you have methods like get elements by tag name, and you could give the name of the element and it would retrieve it as a node list. Now you will have to iterate through this node list to display the contents of it. All right, so here what you do is you iterate through it. So when you get a node list, basically you would get list of nodes. All right, so now what we are doing is we are printing it out one by one. We are printing the nodes or the contents that we have within one by one. So in this case, you can see that when you do student.get elements by tag names, and you can see student here, so this would give the number of student that you have within a document. In the previous example that we took, the number of element is just one, right? We just had entry for one student. So it would iterate just once. In this case, it would iterate just once, all right? And what we are doing here is we are kind of taking again element by tag name, and these are nothing but your actual values or the first name, last name, email, and marks. This loop is going to run just once since we have only one student. And this is how you display the content of an XML. So basically what we are doing is we are parsing it. When we say parse, we are trying to get data, or we are trying to load data into DOM or document, and we are printing it out. Why do we have parsers? Is nothing but to retrieve data. If you want to query out particular data, you could do it. You could write some logic to read out a particular data from an XML. Say, for example, you might have a long XML and you want to read data pertaining to a student Henry. So what you could do here is you could write some logic here saying that if student is equal to Henry, then return mark secured by Henry. So that's why we have XML parsers in picture, to have it loaded into memory and play around with it. All right, so let's see the example of XML reading using DOM. I give the path here as C We give the same file, all right, edureka xml student.xml that we created. Or let me do one thing. So I create one more student here, say for example. Just for simplicity purpose, I'm just putting test last name as the last name, test email, and I put test marks. All right, so these are the values that I've put for one more student that I've created, or maybe I'll put this one as just to be consistent. So we have two students now within. So first one is Henry Lee, and the other one is like we have created a test student. Let me show you when we run this program. What we are trying to do is we are going to read this XML that we have created, and it's going to parse it. Parsing is nothing but it's going to display the contents of it. So it's going to loop through, it's going to understand there are two students within, and it's going to display first name, last name, email, and marks secured by each student. All right, it says the processing instruction. Okay, we can see the output being displayed here. All right, so we can see two students here, the current element, Henry Lee Com, henry123gmail.com and 70. And there's one more student that we added directly into the XML, and we can see it displayed as well, saying that test first name, test last name, test email, and test marks. So that's how we parse it, okay, using DOM parser. And what DOM parser does is nothing but it creates a tree. If you remember, I said it creates a tree-like model that was there in one of the slides that we discussed earlier. It creates a tree-like structure with a root element as your root node, and your leaves are nothing but these values, Henry, Lee, and all this stuff. Whatever is being displayed here are nothing but leaves of your tree. Advantages and disadvantages of using DOM. It is preferred when we have to randomly access separate parts of the document. So if you don't want to do it sequentially, it's preferred that you use DOM. It supports both read and write operation. So we created XML using DOM and we read XML using DOM as well. So the first example that we took about creating a student.xml was using DOM as well, since it was document. Remember, we created object of document and then we inserted all the elements within. That is nothing but DOM. It supports both read and write operation as we saw. And what are the disadvantages of using it? It is slower than other parsers since it has to create tree. So it's a one-time activity that it does. So remember in the second example that we took, we saw parse here, right? There's parse here, document builder dot parse. This is going to take a lot of time because it's going to create a tree. If your XML is big enough based on the size of the XML, it would take time because it's going to create tree. So parse is something that is going to take time. And it's not very memory efficient, since you could imagine if you have a big XML. So XMLs in general are like, it could have like 100 million records within. They are humongous. They are not small XMLs that we are dealing right now. It's coming from different systems, right? So you could imagine their system pushing data in the form of XML and sending it to some other system to process it. So it could be humongous, could grow up to like 100 million records or something of that sort. So imagine that you want to load all this into memory, right? And create a tree. So this parse method is going to take a long time to create a tree. And the other thing is it's not memory efficient because it's going to load this entire document into your memory, right? Which is going to take like a lot of GBs of memory, right? To load it. So it's not pretty memory efficient when it comes to parsing using DOM. So that's the reason we have other variants of parsing, which is not document object model, which is basically event based. So we have like two parsers, event based parser. One is like for push parsing, it is SACS, and whereas for pull parsing, it is stacks. All right, so we'll just go through what is SACS parser and stacks parser. SACS parser is nothing but it stands for Simple API for XML. SACS parser reads XML files sequentially. It's a event based. All right. So when I say event based, what happens is when a parsing event occurs, the parser invokes the corresponding method of a corresponding handler. So basically, you define a handler. You say that if I get so and so tag, or if I get start of a element tag, go to this particular handler. All right. And these handlers are nothing but user defined handlers. So you could say that when I get a start of a element tag, go to this handler and do something, right? It could be as simple as printing it, or it could be as simple as filtering it. So it's up to you to write the logic for the handler. But what the framework does is nothing but when you see a opening tag, it would give a call to your method, all right, your handler method. SACS parser is used when we have a large XML document. As I said in the previous example of 100,000 records that you have within your XML file, document object model is not that efficient because it's going to load everything into the memory, which is going to take a lot of time, as well as memory, which is going to consume a lot of memory. So it's not good in terms of time and space complexity. Whereas SACS does a good job when it comes to large XMLs, when it comes to parsing large XMLs, because it's not storing or it's not parsing everything into a object in one go. It's a event based. So basically you would see that it sequentially goes through the XML, and as and when it sees something, right, start of element, start of an attribute or anything of that sort, it would give a call to handler and handler would process it. So basically it's not storing anything, it's not retaining any information into memory. It is just calling the event handler and just leaving it right there. So since it's not consuming memory, it's good when it comes to large XMLs. But it's not good for random search, right? Random parsing because it goes sequentially. So for SACS parser, again, you could see the files present in javax.xml.parsers.sax parser. Earlier it was document, and here it's SACS parser. Again, you could have this imports done by your IDE. This is what event handler is all about, right? So you are defining an event handler here, which is nothing but a default handler. So your XML reader using SACS is nothing but a default handler. Okay, is a relationship, is a default handler. You extend it. You're extending default handler, which is maybe an internal interface to your SACS parser. Once you extend it, it's not an interface, sorry, since it's extending, it has to be class, all right? It's a class. So the default parser or the default handler would have these methods within, which is nothing but start element, you have characters, you have end element and end document. So these are the methods within, right? When you give a big XML, in this example, or when I say this one, so when it comes to student, which is your root node, it would go to start document. When it reads this XML, it understands that it's a start of document. So it says document begins here. It would go sequentially. This parser, what it would do is it would read this entire file and it would go sequentially. When I say sequentially, then it would understand that there's an element again, and it would give a call to start element. And here what you could do is you could print it. So what we are doing here is nothing but we are printing the XML document using SACS parser, all right, which is event based. Whenever a particular event occurs in your XML, it would give a call to the particular handler. So whenever there is a start of document, in this case, student is a start of element again, which would go into start element, all right? When does it come into characters is nothing but when it encounters Henry. When it encounters Henry, it would go into characters. All right, you see a characters method here, it would go into characters and you can see that it's a character array. All right. So here it would print the entire array, which is nothing but the value Henry and all these leaf nodes, all right? Henry, Lee, and whatever values that you have would be printed by this characters method. Whereas the tag names would be printed by your start element and end element. This would be your end element. All right. So this is pretty much like it's a event driven one. Whenever it encounters something, framework gives a call to a particular method. And this method is user defined. You could do whatever you want to. So this is how you create a instance of it. So you have sax parser factory dot new instance dot new sax parser. You create the instance of sax parser. Now you parse it p dot parse and you provide the handler as well. The handler that you have provided, which is nothing but XML reader using sax. That's your handler. So you have to create the instance of it and pass it over. Let's see this program. And also you could see it is reading students.xml, right? So I'll have to change this name to C Edureka XML. All right, so let's run this program, which is the same program that I spoke about in the slide, which is event based. You could see methods implemented here, and you could see it extending default handler. All right, so there's a default handler, there's start document. Basically, start document and everything is coming from your default handler. All right, and in the start element, we are just printing it, characters. And again, when it comes to end, we are ending it. And when it comes to end of the document, we are just printing saying that document ends here. All right, so we are reading the same student file, and this time it's using sax. So you can see here when it encountered start of the document, it printed document begins here. Then you could see elements printed sequentially. So this is what it is. This is like event driven, right? And at the end, when it reaches the end of the document, you can see document ends here being printed out. So basically, this is, as I said, event driven and this is sequential, right? It goes line by line. So if you say you have like 100,000 records within your XML and say the last entry that you are searching for, it's going to go through the entire XML till it encounters the last element. When it comes to random search, or if you want to search randomly, it's not well suited. But when it comes to big XML, it's much better than DOM since it's not loading anything. So it's not keeping anything into the memory. It's just parsing it, it's just printing it out, and it leaves it right there. So what are the advantages of sax? It is simple, it is memory efficient. Sax parser is faster than any other parser. It handles large document. We spoke about all this right here. Disadvantages of using is client will be unable to understand the whole information because data is broken into pieces. So it's not storing it in one place, it's broken into pieces. It's not even storing it into memory. It's just flushing it off. It's just writing it and leaving it. So what's the difference between DOM and SAX parser? DOM stands for Document Object Model. SAX stands for Simple API for XML. DOM reads the entire document. SAX reads node by node, which we saw. Sequentially, it would go. DOM is useful when reading small to medium size XMLs. SAX is used when big XML files need to be parsed. SAX is good for big, and this one DOM is used for small to medium size. DOM is tree-based parser. We saw it creates a tree, and SAX is event-based parser. We saw how it has event handler, and you saw that it calls a particular method based on the event that it encounters. DOM is little slow as compared to SAX because it has to create the entire tree, and SAX is faster than DOM. Once the tree is created, I think DOM would retrieve it much faster than SAX, but the tree creation itself takes longer time, right? When you parse it, it has to create a document model, which takes a lot of time. DOM can insert and delete nodes. Since it has entire tree, it preloaded, you could actually go and delete it. You have the entire tree loaded, so you can traverse to any particular node and delete a particular node or delete a part of a tree itself, which means that you could do insertions and deletions. Whereas SACS doesn't store anything in memory, it just reads it and just pushes it off. So you cannot insert or delete nodes into your source XML. So basically, it's meant for just doing something or retrieving information from your XML. It cannot manipulate the source XML. SACS parsers cannot manipulate the source XML. Now we have one more, which is stacks. So in terms of SACS, if you imagine SACS, it's a push API, all right? When I say push API, it's nothing but it reads through, scans through the XML, and when it encounters an event, it pushes the handler to handle it. So there's a push from your API to the handler to perform some actions. Whereas stacks, it's a pull API. Let's go through it to understand more. Stack stands for Java Streaming API for XML. Stacks parser pulls the required data from the XML. The stacks parser maintains a cursor at the current position in the document, allows to extract the content available at the cursor. So basically, it maintains a cursor at the current position in the document, which allows it to extract the content available at the cursor. Again, you could see javax.xml.stream. In the first one, the DOM, we had document. The second one, we had SACS. Now the third one, you could see stream. So that's the beauty of packages. You could understand what files are there within. Okay, so using stacks, you could see here we create a event handler, XML event factory.create XML event handler and new file reader. So you pass a new file reader and it's nothing but the XML file that you want to pass. Now you could see that you get all the elements. So basically you have an event reader and you get the elements upfront, or you get all the events that you have within an XML. All right. And you iterate through it now. You have a switch statement which would do the processing for you, which would say, for example, you have a start element similar to how we saw in the SACS parser. So you have a start element, and if it's a start element, an event would be passed and you could actually get the element value. So basically what we are doing here is we are getting all the events and we are iterating through it, and we have a switch statement which is handling the event. So instead of having the event handler written in a separate class, we are writing the event handler in the same class. This is kind of again decoupling, right? So imagine yesterday we spoke about comparable and comparator. So comparable was like compare to method was written within your class, right? Within your model class, which was student yesterday. All right. And again, we had another example of comparator, which had a compare method, which was taking two student objects as an argument. So that's the difference, right? So we are decoupling it. We are writing the entire comparison logic to a different class. So we can imagine the same here. So that's what the difference between SACS and stacks is. Stacks is writing it within the same class, whereas SACS, you have a separate class for event handling. So you could see here pretty much similar to how we did in the SACS. So you can have, like, if it's a character, then you have event as characters, you print the characters. When you encounter end document, you have event as end document, and so on. Basically, you get all the events and you iterate through it, and you have a switch statement handling the event. All right, so I take this example. So the first thing that I'll have to do is change the file name, Edureka XML, and I just run through it. All right, so here we can see start element student. You have first element as Henry and so on and so forth. Again, first name Henry and stuff like that. Again, you can see the same, the second student being parsed as well, which was a dummy student that we inserted. And at the end, you will see end of the element student. All right, so this is how we parse using three different parsers. And we saw about advantages and disadvantages and which one would be apt one per your use. All right, so you have to understand the nature of the application or nature of the XMLs that you are dealing with, and based on that you could decide which parser to go for. So that's about the parsers. Now let's talk about XPath. XPath expression is a query language used to select path of XML document based on the query string. You can create a query string and you can retrieve it using XPath. XPath returns a node set representing XML nodes at the end of the path. Alright, so this is basically like querying language, or you have XPath expression which you could write query. In this example, if I want to get first name of a student with so and so marks, if I want to get the first name of student with 80% marks, right, I could do that using XPath. So basically it's for querying, right? And it returns a node representing the XML nodes at the end of the path. It is used to traverse elements and attributes of an XML document. XPath defines the structure and provides XPath expression. So the 7 type of nodes that can be output of the execution of XPath expression is root, element, text, attribute, comment, processing instructions, and namespace. We'll take a look at it. XPath defines a pattern or path expression to select nodes or node sets in an XML document. What are XPath expressions? You have node name, which is used to select all nodes with the given node name. You define a particular node name and you could select all the nodes within an XML document that has a name as node name. So it could be either element, it could be attribute or anything, but it could be just element name rather. It specifies that selection starts from the root node. If you have one slash, it says that it starts from the root node. It specifies that the selection starts from the current node that match the selection. All right. So slash scans the entire document. Slash slash is nothing but the current node. Dot is again select the current node. So whatever node you are at during parsing, it would print it out. Dot dot is parent node, and at the rate is it selects attributes. So if you want to query out certain attributes like at the rate id is equal to 10, say the employee id is being stored as an attribute, and if you want to have employee id with value 100, you could query out saying that at the rate id is equal to 100. Steps to use XPath. Again, you have XPath related packages you have to import. You have to create document builder. You have to create an XPath object and XPath path expression. Create a document from a file or a stream. So basically, when you are creating document is nothing but it's a DOM based parser. Basically, it's not well suited for big XMLs. For small or medium sized XML, it's good enough because it's creating document out of your XML. Then fourth, create an XPath object and an XPath path expression. First, you have to create object and you have to pass the expression that you want to retrieve. Compile the XPath expression. First, you have to ensure that the XPath expression that you have provided is up to the mark and it doesn't have any error, and you're following the contract that XPath expression has. Iterate over the list of nodes. Once you get the result of the XPath expression, you have to iterate through the list of nodes, which is nothing but the result, and examine attributes and examine sub elements. All right, that's a typical way in which you would use XPath. So you could see here, it's again javax.xml.xpath. There's a separate package for it, and it will have all the classes related to it, like XPath factory. You have constants, and you have like exception, and you have XPath class itself. Here we are again parsing students XML. We parse it into a document first, as we mentioned the steps that we spoke about. We create the document and then you apply the XPath. You have an expression here slash class slash student. All right. And then you compile this expression, whatever expression you have here, you compile it and you then evaluate it. So evaluation is nothing but you are iterating to the result and you are printing out the result that you got. To broadly classify, what we are doing here is we are creating a document object out of the XML file. And the next step that we do is we compile the expression and then we are evaluating it. Evaluation is nothing but doing something with the result. there are a couple of checked exceptions that you will have to take care of. So you could see that it's been handled here. It's not specifically handling it, it is just printing out the stack trace. So let me quickly take this example. All right, so from here, I go to resources. So let me go to documents, downloads. All right, so let me run through the same example and see if it runs. All right, so we have, I take the same example, C. So I go to C at Eureka XML. Okay, so let's see if it runs. So it didn't find .txt. So I changed this to XML. Okay, let's try to run. So what I'm doing here is pretty much passing this XML and then reading it through. So basically, just to again tell you, I'll have to see why it's not running at this point, but it's more about you just create a document model, you have your XPath set, or you have the XPath expression, you compile it, and then you evaluate it, which is nothing but whatever result you get, you can do something on it. All right, let me move on to the next slide. DOM4j is an open source Java based library to parse XML document. DOM4j is flexible and memory efficient. It integrates well with DOM SAX APIs. It should be used when you need the information in an XML document more than once. So basically, with SAX, if you want to parse through more than once, if you want the information from the same XML more than once, it's not that efficient because it will have to parse it again. So it doesn't store anything, it has to go through it again. Whereas this one is something that integrates well with DOM and SAX APIs, which allow developers to use the information in an XML document more than once. So what are the steps? So basically you have to download this dom4j.jar from the website or from the GitHub. So there's a GitHub mentioned above. So you'll have to go and download the latest version from there. So once you have that library, this is a common thing that you do in Java. You download a jar file, you can go and download any particular jar file that you opt for. When I say jar file, it's nothing but the third party Java archive, which is nothing but it's a group of classes together doing something. You can download any jar into a specific directory and you can add it into your application. There could be a third party, say for example, I want to add two numbers, or say for example you want to do some big data processing. Java by itself doesn't have a big data processing library or framework. So what it would do is big data framework will have a jar file exposed, right? Which is, say for example, Apache. Apache is a provider which is providing solution for big data, right? So you would have the libraries or you would have everything coded into a jar file for big data processing. Now you need to import that jar file into, or you need to link up your application to that particular jar file to leverage big data processing in your application. So in that typical scenario, what you would do is you would have this jar files downloaded into your local directory and have you could add those external jar files, or this is how you link to your applications. All right. So you go to Java, you right click on your application, go to build path, then you click on Java build path here, and then there's a button here to the right which says add external jars. You would have a jar file, in this case dom4j 2.1.0. You have this jar files here. Now you link up to your application and you click on that and you click on open. That would add the jar file to your application and you can apply and close. So now you could leverage that particular jar file or the functionality that is exposed by the jar file into your application. All right, in this case, it was DOM4J. Introduction to JAXB. JAXB stands for Java Architecture for XML Binding. It's a specification actually. JAXB is used to write Java objects into XML and vice versa. All right, so you could write it or read it. What are the features of JAXB? It supports for all W3C schema features, right? All the standard W3C is a standard, and all the features that you have in W3C, it has a support for it. It reduces a lot of generated schema derived classes. It cut downs rather on the generated classes, schema derived classes. Small runtime libraries. In terms of size, it's pretty lightweight. It provides additional validation support by JAXP 1.3 validation API. It steps to convert Java object into XML. Create a POJO or bind the schema and generate the classes. So basically JAXB is nothing but from the schema, you can create your class. All right. If your schema says like, remember we had an XST wherein we saw that it was like an XML, which you could read through, like you could have a schema. If you remember, we had a student schema wherein we declared this is what the format of XML would be. You could have the name, you would have student as a starting tag. We defined the sequence as well, like first name should be first, then last name, then email address, and then marks, right? We define the sequence as well. So that is nothing but that's a schema, that is XST. So when you use JAXB, what you do is from the schema, you can create Java classes. So basically schema is nothing but schema tells this is what an XML can contain, and from schema, you can have Java classes created. So there would be a Java class by the name student, and within student there would be string. So remember we had the data type put in the XSD as well, like first name would be string, last name would be string and stuff. There's a mapping between this data type and Java data type. What it would do is nothing but it would create all these properties or all the properties that you have, all the elements, sub elements that you have within student. There would be a corresponding property created in a Java class. So basically, this Java class could be thought of as a container for your XML, right? You could parse them into this Java class, and that's where JAXB comes into picture. It's a binding. It binds your XML into this Java classes. All right, so create JAXB context object. So the next step is to create JAXB context object, then create the marshaller objects. You have to marshal and unmarshal. So in this case, since we are going to do from POJO into XML, it's going to be marshal method, all right, marshalling. Create the content tree by using set methods, all right. Whatever you want to set, you're going to set it into Java object. So unlike earlier in the DOM example that we took, we were actually creating the tree, if you remember, append child and stuff like that, which makes it very difficult to understand, right? Which is difficult to maintain, and if you miss something, it's cumbersome to actually maintain it. Now you have a student class wherein you just have to set into the student class, all right? So create the content tree by using set methods and then call the marshal method to convert this class into an XML. We have a student class, and within student class, you would have all the properties created, which is derived from your schema class, from your schema XSD, or rather schema and XSD mean the same. And what you're doing here is you're going to set it into set values that you want in the XML into the instance variables in this class student, and we are going to marshal it to convert this into XML. So basically, rather than creating XML on your own, what you're doing here is you're using the marshal method to do it. So once you marshal it, you should be able to get the XML. So let's understand JSON. JSON is nothing but JavaScript object notation. We will look at the format of it very soon. It is easy to read and write than XML. XML is a bit cumbersome when it comes to reading and writing, and it occupies a lot of memory as well. JSON is language independent. Similar to XML, it's language independent. It is lightweight compared to XML, and which is nothing but lightweight data interchange format. XML is a data interchange format as well, and JSON is pretty much like the same. It's used for data interchange, or it's a medium of communication between two different systems. JSON supports arrays, objects, strings, numbers, and values. So most of the RESTful APIs, which is nothing but a web service built upon HTTP, mostly they use JSON for communication between client and REST API systems. So this is because it's pretty lightweight and it's lighter compared to XML. And as you could imagine, since it is across networks, since communication is happening across networks, you need to have lightweight system or lightweight medium, or else it would occupy a lot of the bandwidth between communication. Just because it is lightweight, it's preferable interchange format. Difference between JSON and XML. JSON stands for JavaScript Object Notation. XML stands for Extensible Markup Language. JSON is simple to read and write. XML is difficult to read and write. So we have been looking at the examples, which were not pretty straightforward, right? We had a lot of code to be put in. So it is difficult to read and write. JSON is data oriented. XML is document oriented. JSON is less secured than XML. XML is more secured than JSON. JSON supports only text and number data type. XML supports many data types as text, number, images, charts, graphs, etc. All right, so it has restriction with the number of data types that it can hold. JSON object holds key value pair. We took example of student earlier in the form of XML, right? Wherein you had first name, last name, and marks. This is the same example, but in JSON. So here you could see opening brace and closing brace, and you could see student is a key and followed by colon. And again, there's an opening brace and closing brace for student, which means it is saying that student is an object. If you have value as which starts with opening brace, which means that's a object. The second one is as you get deep into this particular object, wherein you see first name, right? First name is the key, and you see a literal, which is Henry as the object, as the value rather. And as you can see here, a Henry is not an object. That's why you don't have it within braces, which means it's a literal value. All right. Again, you have last name and D'Souza, which is a literal value. You have Marx and 50, which is a literal value. Just to summarize, whenever you have colon, to the left side of the colon is nothing but the key. To the right side, it's a value. And if you have a value starting with quotes, which means that it's an object, it's a complex object, or you have multiple things within it. So in this case, you could see that within an object, you have like three things put in, like first name, last name, and marks. Basically, student can be mapped to some object in Java, which will have first name, last name, and marks. So each key is represented as string in JSON, and key is always string in JSON, and the value can be of any type. JSON array represents order list of values. It is always ordered. JSON array can store string, number, boolean, or objects. It can have string, it can hold number, it can hold boolean, or any other object as well. So here you can see the first example is array representing days of a week, and you could see Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday put in there, right? You could see another example is students, and within students you could see it as students is nothing but array of student, and each student has first name, last name, email. So basically this is how you could interpret it. So students is nothing but it's an array. So the key is students here. Let's see how to run it. So the first thing that you do is JSON simple. So you can see here a jar file is already downloaded, which I would be using. So we have like JSON simple. All right, so it's not there. Let me see. So whenever you want to deal with JSONs, the first thing that you would do is you have multiple APIs though, but in the slides to come, we are referring to JSON simple jar. So the first thing that I would do is I would download JSON simple jar. All right, so I go. So you could go and download this JSON simple jar. Okay, usually nowadays we don't do this because we have other build tools like Maven. Maven is a build tool, and you have a file, XML file, wherein you provide all the jars that you want, and it would download it by itself. So it has got a repository from which it would download all the jars. You don't have to explicitly put it, but I don't want to confuse at this point with Maven. Let's do it this way, downloading it and then linking it. All right, so it's connecting. Basically, we are downloading the jar, right? And you could see it has downloaded it. It's pretty small, like 20 KB jar, because those are all class files. It's Java archive, which is nothing but class file. So I take this and I kind of unzip it. Okay, so I get this directory here, and you should be able to see a jar file. Now, this is nothing but an executable jar file. You could see it here. You could see the type as executable jar file. All right. So now I put it into, for simplicity, let me put it here itself. All right. So I create a new folder, which is edureka JSON, and I put it here. So now we'll have to link up our application with that. So what I do, so when we had this DOM4J downloaded and linked up, we'll have to do the similar stuff for this thing as well. So since I'm using IntelliJ, the steps could be different than Eclipse. But basically what you do is you go into, let me see the option here. There's open module settings. So you go to the open module settings tab and you would see something of this sort coming up. All right. So now I want to add something, right? Add a particular library. So I go to libraries first. I click on add Java, and I traverse to the path that I put the jar file into. So I had put it into edureka JSON. I select this jar file. I click on OK. So this is basically you're trying to link your application to a particular jar file. All right. So you could leverage it. So here you can see that there's this jar file that will link to your application. All right. I apply it, which I already did, and I'll click on OK. Okay, so that's how you link any executable jar to your application. So you go to the build path, you go to, this is how you do it in Eclipse. Like in IntelliJ, I did module settings, whereas in Eclipse, you would go to the build path, you would go to the add external jars, and you would select the path and then apply and close. So this is how you do it in Eclipse. So encoding JSON in Java. How do we encode JSON in Java? How do we write a JSON? How do we actually create JSON in Java? All right. So I had to comment this earlier. Now I uncomment this. So there was some error earlier. Now let me try resolving it. Okay, it's taking long. So it's asking me which Java class to resolve. So there's a JSON object class. We'll have to see. So let me select this one. So I have a JSON file. So similarly, I would prefer, just to keep best practices, I would say JSON object, and this is like private method. The return type is JSON object, and I say create JSON. All right. And I would prefer to put this here rather than in main method. That's one of the best practices, by the way. It's not something that you have to do, but as I said, I prefer to write something like this. Give a meaningful name, something like this. So I'm just iterating through this so that you get to understand what are the best practices. It's not mandatory. So I say student JSON, then I say student. So this is to make it more readable. Tomorrow, if I come and look at it, I would be able to understand. And maybe, as I said, there would be many other developers who would be looking at the same code that you have written. In order for them to understand and to increase the maintainability and reusability factor as well, it's better to write like this. All right. And then I could even say private void print JSON, and I take the JSON object. You have a print method which is taking JSON object, and say I call it as JSON because it could be any generic JSON, and I print it out saying JSON. All right. So you have new JSON encode. I create an instance of it and I create JSON. Now this JSON object, which is nothing but student JSON, it's going to be here, and I'm going to call new JSON encode dot print JSON, and I'm going to pass the student JSON here. So we have created a JSON here with first name, last name, and email address, and we have marks as well, and we are printing this JSON there. So I have run it. Let's see what it shows up. So JSON is pretty much lightweight as compared to XML, as you could imagine, right? XML has all the start tag, end tag, and stuff like that. So when it comes to a humongous big chunk of data, like millions of data you're processing, you could imagine the size of JSON, size of XML would be pretty much high as compared to JSON, since JSON is just doing it in the form of key value pair. You don't have to end it, you don't have the end tags and stuff like that. When it comes to readability, I think in terms of readability, XML could be better, but when it comes to size, this one is better, JSON is better. So machine to machine interaction, JSON is better, whereas readability, I think XML could be at times more readable to humans compared to JSONs. All right, so here you can see JSON being created. So again, if I want to format this, there are online tools. Since these have widely become standard for data exchange standards, you have a lot of tools dealing with it. All right. If I want to do online tools itself, rather, if I want to do JSON formatter, I have JSON formatter as well, which is online, and it's validating as well. If you miss something, if you don't have a empty braces or if you don't have a closing brace, it would give you an error. All right. So if I do this, you can see that it formatted it and it has given you to collapse and expand. So you could parse through and understand more about this JSON. Also, it validates it. So if I remove this curly brace and if I try to do it, it would say it's an invalid JSON. So if I scroll down, it shows invalid JSON since it was expecting closing brace at the end. I put this braces and it should be back up again, be able to parse it. All right, so that's about JSON. So what do we have next is creating JSON file. So you could write it into a file. Basically, what you could convert it is into a string and you could write it into a file. All right, so if I want to write here, say I want to write to file and I say JSON object. If I want to write this JSON object into a file, what I would do is say I do it using file writer and I take the file name as well, say for example, or string, or it should be absolute file name. All right, so it's absolute path of the file name. So I do F, or maybe I can use it within the file writer, right? So I create a file writer, which is nothing but JSON file writer, since we know that it's going to write just JSONs. All right, I create the instance of it. Now, what does it take? So we have created a file writer for writing. It is showing some exception. remember we have to add exception to throw it. Now what I do is JSON file writer dot write. I'm going to write this thing JSON object as a string. Okay, so JSON dot to JSON string. All right, I got a string and I would write it into a file. Now what I do is JSON writer dot flush. I would flush whatever is been buffered, and last thing that I would do is close it. So one thing to remember is you should always close it. If you don't close it, it's going to remain open, and which is going to consume a lot of your memory at the end, which might become a bottleneck for your application. So remember, you whenever you deal with file, you have to close it at the end. Now what I do is I create a new instance of JSON encode, and I kind of write to a file. Okay, write this to a file, and I need to provide file path as well. So I say edureka JSON, and I say student.json. I have to handle the exception here as well. If I want to handle, I can handle it, or else I can choose to throw it off. So in this case, I have thrown it off. So you could see the program executed successfully. Now let me go to edureka JSON, and I see student.json here. Okay, go to C, I go to edureka JSON. I just open it up, and you should be able to see student.json has all the fields that we have put in, right? First name, marks, email, and this thing. So yeah, we saw how to write it into a JSON file, right? So we have created a JSON file, and we have similar thing like how to read it from a JSON file. You have like JSON parser, which is again, you need to pass your file reader, and which would pass it into a particular JSON object. So from your file, you are basically converting it into a JSON object, and from JSON object, you can read whatever data you want to. Again, give you an example, you could have private void read JSON, and you could have string, say absolute. All right, so you have this. Now what I'm trying to do is I'll create a new JSON parser. You can see here there's a parse method which takes file reader. All right, so I do dot parse. All right, and you could see there's a second method here which is taking reader. All right, so what I do is parse new file reader. File reader is nothing but is a reader. That's why you can use it there. And I give absolute path name. All right, so this should parse your JSON. So it's asking me to import it. I imported it. So there's file not found exception that I need to handle, which I'll rather throw it off. All right, so as you could see here, I have thrown off file dot. There's other exception as well that I need to handle, which is nothing but IO exception, which is again, I've thrown it off. All right, so we have parsed this. So on parsing, what do you get? Is nothing but object. You get JSON as object. All right, you have parsed it and you have got JSON as object. Now what I'm going to do is I'm just going to print, say, one of the attributes, not all, since it's going to be the same. I'm going to print the first name. So it says there's no method. Let me see. So you have this. It cannot be taken as object directly. It has to be taken as JSON object so that we could read it. All right. So this has to be typecasted to JSON object. This is basically typecasting. All right. What is typecasting is nothing but you know what is going to be returned out from the parse is going to be JSON object. So we can do it something of this sort. All right. once you do this, you can get based on the key. So I give first name key. Let me print the last name as well. All right. And let me print the email as well for convenience. So basically we are going to read from this. So it's first name, last name, and email. As we can see, first name is lowercase, so this would give an error. So we have parsed it as well. All right, we have read it from JSON file. Now what I do is I'll have to give a call to this, which is nothing but JSON encode dot read JSON, and I pass the same file here. All right, now it is asking me to handle the exceptions. So I add it to the method signature as I choose not to handle it. All right, so what we have done here is nothing but we are parsing the JSON file. All right, so we have a read JSON method which is taking absolute file name as its parameter. We have a JSON parser class, which is one of the classes from the jar that we downloaded, JSON simple jar that we downloaded. And since it's put into your application, since we have attached it with our application, we are able to use those classes, right? If we wouldn't have done that step of linking the library with the application, you won't be able to use these classes, okay? Because these are third-party classes. This is not as a part of the standard Java kit or SDK that comes with Java. We had to download it and then link it up with our application using module settings, or if you are on Eclipse, then it would be configure build path. And then you parse it and you provide the reader, instance of reader. In this case, I passed file reader and I gave the absolute file name. Once this is done, you should be able to read messages or read the content or read the keys that you have within your file. You get JSON object, then I do JSON.get first name, then I do JSON.get last name, and the last thing that I'm printing is email. All right, let's see if this works. So I'm running this. You could see the value being printed here. First name that came out as John, then the last name that is Lee, and the email that we printed that is John@123. All right, so that's about XML and JSON, which is nothing but it's a standard set across industry for data exchange. So yeah, having said that, one of the main differences between XML and JSON is it's lightweight, and most of the companies or the industry is moving towards